All right, so week 2, day 1, exponent review. List of things to remember. The very first thing that you have to remember is that negative exponents have to become positive. So again, two small examples right there. Nothing with numbers, I know, but just generally. If your power is negative in the numerator, change it to the denominator and make it positive. Or if it's negative in the denominator, move it up to the numerator and make it positive. That's number 1. Number 2, multiplying the same base adds powers. Okay, so x to the a times x to the b would be x to the a plus b. And then dividing by the same base subtracts the powers. So that's going to give you x to the a over x to the b equals to x to the a minus b. So you'll just be subtracting the numbers. And remember what I told you guys, if you still have negative powers at the very end once you have your answer written out, then fix that, right? If it's negative on the bottom, move it up. If it's negative on top, move it down. And it'll become positive when you do that. So this first one right here is doesn't have any fractions, so that means that we don't have to worry about numerators and denominators yet, okay? But we can fix things, okay? We can kind of combine some things. Now there is something there that I didn't speak of, but it's something you're supposed to know, but just a real quick hint. Any base to the 0 power is equal to 1. Okay? So if I may, I'm going to just rewrite this really quick, just so we can get something out of the way. So 3 times 1, y to the negative 2, times 6x squared, y to the 4th. I'm just writing down the steps, okay? Just a step at a time. And 3 times 1 is 3, so I'm just going to write it like this. 3 y to the negative 2 times 6x squared y to the 4th. So I know that was a lot of steps to kind of just clean it up, but I'm just showing you all the steps that you would do. Usually a book would show you this, okay? So now that we're at this point, I notice when I want to multiply, I can do the variables, I can do the numbers. So let me do the numbers first because those are easier. 3 times 6, that's 18. So that's pretty easy. And then I like to do my variables alphabetically. So I see x, right? X squared. There is no other x there, okay? So I'm just going to write x squared. And then now I have my y variable, right? Y to the negative 2 times y to the 4th. Y to the negative 2 times y to the 4th. Now, since they have the same base, that means I get to add the powers, right? So what's negative 2 plus 4? That's going to be 2, right? Now I'm just going to write it down just so that someone who's not here can actually see that. But that's going to be y squared, and you're done. That's it. Now I did a lot of what some people might say unnecessary steps, right? Like this step right here, some people would be like, why would you even write the 1 there? If you know it's a 1, then just don't write it on the next step. I know. And this step right here is considered unnecessary for some because they're like, well, I can do that in my head. I don't have to show it, right? But again, it's just some work in case people need to see it. So it doesn't really take a total of 4 steps. It usually is about 2, okay? But you do whatever it is you have to do. So if you have to take all 4 steps, take all 4 steps. If not, take less. Are we okay with that example? So here's one that has fractions. Now, before I do any division or anything like that, or any movement of negative powers, I'm going to look at my numerator first and ask myself, is there anything that I can do to it that's going to make me combine stuff? So I notice I have a 5, an A, and a B. None of them have like bases, so I can't combine them. So my numerator is kind of just stuck there. Not much for me to do. On the denominator, I just have a 3b to the 5th, so also not much for me to do. Okay? So since I really can't do anything in the numerator by itself and in the denominator by itself, now I got to start looking from numerator to denominator. And I notice I have b's that are there, right? B to the negative 1, b to the 5th. Okay, so this is what I'm going to start off doing. I look at my 5 over 3. I can't reduce that, so I'm just going to do this. And this is usually what I do. I know it's a pretty long fraction bar, but I'm just going to leave it like that. Now, my a term. There's nothing else I can do to the a on top. There is no a on the bottom, but it says a to the negative 2 power. So I got to fix that. So that's going to become a to the positive 2 power on the bottom. Okay? And then my b term, well, I know I have one on top and bottom, so I'm going to write, you always put it on the numerator, okay? Whenever you're going to do your addition and subtraction, always put it on the numerator. Negative 1 minus 5. Again, I'm taking steps, all right? So if you're doing it faster, that's fine. Well, negative 1 minus 5 is negative 6. So that's 5b to the negative 6 over 3a squared. Remember what they told us, don't leave any negative powers. So that b to the negative 6 on top is going to have to go down. So that's going to be 5 over 3a squared b to the 6th. And again, I'm doing this by showing all steps that would occur. You don't have to. But it would look something like that. So notice, I realized my fractions can't be simplified. 5 over 3, I cannot simplify. My a term, I had an a to the negative 2. And that's the only a term I had. So I did what I can do with it. I moved it down. That's all I can do with it. And then my b terms, I realized I had one in the numerator, one in the denominator, so I can actually subtract them, right? Subtract the powers. But when I subtracted the powers, I ended up with a negative number, which means I have to move it, right? If it's on top, move it down. If it's negative on the bottom, move it up. Okay? That's up to you. Now, there are some teachers that tell you to move the negatives first. So, you could have also done it this way. And I don't know if you had a teacher that made you do this first, but there are some teachers that would have told you, look, you're going to have to write it like this. Oops, b to the 5th. Does that make sense? All the negatives moved, right? And then notice on the bottom you got b to the 5th times b to the 1st. That would be b to the 6th. So this would be 5 over 3a squared b to the 6th. Same answer, right? No different. So I don't know if you, I know you've seen this before, and I don't know how those teachers taught it to you guys. Sometimes I do it the way it's written in red. Sometimes I do it the way it's written in blue. It just kind of depends on what I think is easier for that problem, okay? So if the problem is kind of difficult and there's too much stuff going on, then I'd rather just go the way of the red ink and say, okay, I'm just going to work it down slowly. But if it's not too complicated, sometimes I do it the way that it is in the blue ink. I move stuff first, okay? It doesn't really matter. It's up to you, okay? Whatever you prefer, it's going to work just the same, okay? Just make sure you follow the rules, right? Negative powers move. Okay, add the powers if you're multiplying same base. Divide the powers if you're, subtract the powers if you're dividing the same base. So whichever way you prefer, it'll work, okay? So something like this, me personally, I would simplify first. I wouldn't move my negative powers and stuff. I would just multiply tops, multiply bottoms, do whatever I can. Okay, and then after that, I'll do my movement of my variables if I have to. Just give me a little bit of time here. So we got y squared times y cubed times 2x squared times, I forgot to put that right here, times y to the negative 4. So I'm going to try to clean up the top. There's a lot of y's up on top, right? So I'm going to try to clean that up. The bottom looks pretty much clean. Okay, 4x squared, y squared, none of them are alike. So I'm just going to leave it like that. But the top I can definitely do something with. So here we go. So I see a y squared, a y cubed, and a y to the negative 4. Right? Those are all the same bases. That means I can add those powers together. So this is what it's going to look like. Well, actually, before I do the y's, let me move the 2 to the front, because the 2 is not going to do anything to the top numbers. But don't forget about those y's. Okay, remember, I want to do this alphabetically. So I put the numbers first. Now, the letters x, well, x is just x squared. Not much to do with that. Now let's take care of the y's. It's going to be y to the 2 plus 3 plus a negative 4. Okay? On the bottom, it's still going to be 4x squared y squared. So 4x squared y squared. On my next step, I'm going to reduce. 2 over 4 is the same as what? What's 2 over 4? I can reduce it to a half, right? So it's going to be, I'll write the 1 there. 1x squared. Y to the what? So it's 2 plus 3 plus a negative 4. What's my power that remains? So I got 2 plus 3, that's a 5, right? And 5 minus 4, that's a 1. Over here it's 2x squared y squared. I can cancel out x squared divided by x squared, right? They're identical. So I can get rid of them. So all I have is 1y to the first, 2y to the second on the bottom. Well, I can subtract 1 minus 2 for y. So let me write this out. I'm going to kind of move it over here to the side. This is 1 y to the 1 minus 2 over 2. Okay? So the y values, right? Y to the first divided by y squared is y to the 1 minus 2. Now, 1 minus 2 is negative 1. Okay? And I can't leave my answers with a negative power, so that means I got to bring that down. That becomes 1 over 2y to the first, or just 1 over 2y. So this would be your answer for this one. This one's a little bit more complicated in terms of the addition of the powers and then subtraction of the powers. But that's one of the reasons why I like to show all my steps so you can see how I did it, right, little by little. You can take as many shortcuts as you'd like. I know some people will say, well, at this step right here, I'm going to use the blue color. On that step right there, sometimes people will say, well, I know that there's 2 y's on the bottom and 1 y on top, so can I just cancel 1 from here and make this a 1 and write it as 2 y on the bottom like that? Yeah, you can. You can do that. Okay? There's nothing wrong with doing that. But I'm just showing you how it works with the subtraction portion if you didn't know that you could just cancel stuff out. Right? So in red, I'm showing you all the steps based on the properties, right? Add and subtract powers based on whether you're multiplying or dividing them. But if you want to, if you can find shortcuts and say, oh, I can cancel this, I can cancel a couple here and there, go ahead and do that, right? Whatever works. They're all good methods to do the work, okay? So whatever you feel is more comfortable for you to do, then do that, okay? So aside from that, they're going to make us solve for exponents. Okay? And I put just the definition there that you're supposed to know. In order to solve, you must have the same base. So if you have x to the a equal to x to the b, then you can get their powers and set them equal to each other to solve. So you got to make sure that their bases match. If the bases match, then you can set up an equation for the powers. So if x to the a is equal to x to the b, then a must be equal to b. So look at the first problem. Now this is kind of like an easy one. I have 6 to the negative 2x plus 4 equal to 6 to the negative x. Obviously, the bases match, right? So if the bases match, then I can get the powers and set them equal to each other. Now let me add 2x to both sides because that's the smaller of the two variables. So 4 is equal to x. And that's your answer. You're done. So as long as your bases match, then you can set the powers equal to each other. Okay? And just solve. Now, of course, they can get a little bit more complicated, but there are some that are like this, just very simple. The bases are already set equal to each other, so you just got to get the powers and set them equal to each other. Here's another one. This one is thought of as being an easy one too, but it doesn't look like it at first, because right now I have a base of 2 and a base of 16. They don't match. Okay, but can I rewrite 16 as a base 2? 2 to what power? So 2 to the first is 2. 2 to the second, 4. 2 to the third, 8. 2 to the fourth, that's 16. So I can rewrite this. 2 to the x plus 5 equals 2 to the fourth. And now my powers match. My bases match. So if my bases match, I can get the powers and set them equal to each other. X plus 5 is equal to 4. Now if I subtract 5 on both sides, x is equal to negative 1. And that problem is done. So if your bases don't match, you can try to make them match. So that's a nice little trick to solving these things. So here's another one. The thing about this one is that all the bases match. But the property doesn't say that if you have multiplication of the same base equal to the same base, then you can set the powers equal to each other. It doesn't say that. It says if you have a base and a base, just two bases equal to each other, right? Right here I have like 2 on the left and 1 on the right. That's 3 of them. I need 2. So first I'm going to combine the left side. They both have a base 4. So I can add their powers together, right? So I'm going to write 4 to the negative 2x plus 2x plus 1 equal to 4 to the 5th. And then what you're going to do is you're going to add this stuff together and then solve if possible, right? You'll add the powers together and then you can set the powers equal to each other. So let's do that. Negative 2x plus 2x is 0 plus 1. So this is 4 to the first equals 4 to the 5th. Now, according to definition, if the bases are the same, then the powers must be equal. But that's not true. 1 is not equal to 5. So this is a no solution. Now, if the x's would have not canceled out, we would have been able to solve. Okay? but in our case, the x is canceled out. Remember, if the numbers are not equal, you write no solution. If the numbers are equal, you write infinitely many solutions, IMS. Okay, that's from way back. But yeah, whenever you eliminate the variable, you look for truth. If it's not true, no solution. If it is true, infinitely many solutions. So in our case, 1 is not equal to 5, so there's no solution. We got one more of these, and I'm doing a lot of these because I didn't make this review worksheet, so they gave a lot of different types of problems. I like to give you like at least pairs, that way, you know, I can give you a couple and it'll match up with other stuff. But these are a little different. So here's the last one. Okay, 5 to the negative x times 5 to the negative x plus 2 is equal to 25. Now, as you guys can see, bases of 5, base of 25, not going to match up. But I can write 25 as a 5, right? 5 what? 5 to the power of 2. Yeah, 5 squared, right? So I can do that. And the two 5s on the left side, I'm going to have to add their powers because they are the same base. We're multiplying them, so we're supposed to add their powers. So here we go. Let's make those match up. So I got 5 to the negative x plus negative x plus 2 is equal to 5 squared. Now, negative x plus a negative x is a negative 2x. It's not 0. It's negative 2x plus 2. So I'm going to write 5 to the negative 2x plus 2 is equal to 5 squared. Notice I have the same bases, right? Base 5s. That means that my powers, negative 2x plus 2, has to be equal to the other power. So negative 2x plus 2 has to equal to 2. Now let's subtract 2 on both sides. So that's negative 2x equal to 0. And if I divide both sides by negative 2, x is equal to 0. And this is what you guys have to do for homework today.